This recording is meant to help you with your homework for the weekend. And this was assigned on April 7th and due on 10th, which is Monday. So the first question is just define molar mass. Very, very simple. The second question here, number 16, is actually asking you something very different. It's a conversion factor, and the conversion factor is just the fractions that you've been using to do your calculations, like all this last week. So if you look over here on the left-hand pane, there's an example in your book of one of the types of problems that you have been doing. The only thing that's different in the textbook is that they don't put this number over 1. This is obviously the given, and it would normally be over 1 the way we're calculating. So what I'm saying over on the other side there in my explanation is that this equality that you see here on the right that I've used as an example has become this fraction, which we use as a conversion factor. And this takes us from grams to moles. So what we want you to do here is what conversion factor should be used to convert from mass to moles? And then how does that same equality that made this guy give us the answer to this question, which is moles to mass? It's just one is the reverse of the other, and the fraction is upside or flipped from one to the other. And you need to explain that in words that make it clear. Now, in number 17, we're thinking of explain steps needed to convert the mass of an element to the number of atoms of the element. And as you know by now, that is the free fraction type problem. And so any element you like, you can use for an example. That's what I'm reading over here. Will show the equality that will convert any mass, any given mass in grams to your element in moles. And then next, show an equality that will change the moles of your element to atoms. Show your calculation and explain what each fraction accomplishes. That's what I'd like to see in your answer for this. In this one, thinking critically, the mass of a single atom is usually given in the unit AMU. So AMU, you don't have to have a big 10 to the minus 23 or anything of that nature. You've just got the same units that are in the periodic chart can also be considered to be AMU units. Okay, it's just 6.02 times 10 to the 23rd difference is all. And so the AMU is nice when you're talking about atoms, and moles are nice when you're talking about grams. Okay, AMUs are for a single atom. Moles are what we use when we're talking about the molar mass of 6.02 times 10 to the 23rd. So, would it be possible to express the mass of a single atom in grams? And I've given you some big hints over here on the right. And if you will use those, and your example can't be with helium, but you could use any other atom, make it a low-numbered atom so you don't have big numbers to mess with, and go ahead and work it out. Because whatever number of grams equals 1 mole, it's the same number of AMUs that equal 1 atom. Okay, so probably should have put this guy backwards, where I had the 4 AMUs equal 1 helium atom, so it matched this. But I think you get the idea. These two equalities can be made into two fractions that will solve your problem. So I hope you find that helpful, because I think a lot of you may find that difficult to understand. So sequencing, this one's pretty easy actually. All you have to do is convert moles of argon to grams, and you just do that with molar mass, and then convert your atoms that are given into grams. And converting the atoms to grams, of course, is going to be a 3-fraction type problem. This one is just 2. Then you can easily compare all of the 3 guys given, okay, which are over here, the largest to smallest, smallest to largest, I'm sorry, 1 mole of argon and 3.0 atoms of neon, and they gave you the krypton already in grams. So I hope that makes it easy for you to do the homework, or easier anyway, and we'll see you on Monday.